Hello students, I will be doing a short review to practical 1 and thanks very much to the students for providing the sample scripts. This is the first practical that you did since last year. So we are doing on titration. This is a titration skill which you should be quite familiar with. Okay, so the aim of this experiment is to determine the concentration of hydrochloric acid solution. And of course, in our case here, the hydrochloric acid solutions provided to you, the concentration will not be known, but you are told that it's approximately 1 mole per dm cube over here. Okay, and after that, you are given Fa2 with a fixed concentration of 0.1 moles per dm cube, and this is sodium hydroxide. So this is essentially a acid-base neutralization titration, and you also notice that the concentration of Fa2 is about 10 times smaller than that of Fa1. This is quite crucial for you to know because later on I think there is a question that asks you why can't you titrate Fa1 with Fa2 directly. Okay, so in this experiment you're going to perform dilution on Fa1, and then after that you're going to titrate against Fa2 using a indicator that you may not be familiar with. Is known as thymol blue. So that is something that you might want to take note of because you're going to use it quite often in H2 chem. Okay, then after you're going to calculate the exact concentration of HCl. Yeah, do take note that because you're supposed to calculate the exact concentration of HCl, right? In the course of a calculation, you should not be touching 1.0 at all. Okay, so this value is to serve as a reference point. So that means that at the end of the calculation, right, your value will be quite close to 1 mole per dm cube. Okay, yep. Then the procedure, I will not go into details because you have already done the practical. So it involved dilution using the volumetric flask. Okay, otherwise we call it the standard flask. Okay, so you're going to pipette 25.0 cubic centimeters of Fa1 in. So this is over here. And then after that, you're going to prepare, and then remember that in the course of the experiment, right, you should ensure that the volumetric flask is stopped all the time. Yeah, so even later on when you are going to pipette out the solution, right, you should swirl the solution first and pipette the solution out after that, and then after that you stopper it. Yeah, you should not be leaving it unstopped. This is quite an important part of the practical skills you need to be aware of. Okay, and then of course the titration is not very inspiring because it's quite standard, but of course some of you have already heard from me, and then when I review the ideas in the class, I did mention that a lot of you have not so good titration technique. Yeah, so because of that, a video has been made, and you can see it over here. Okay, for this acid-base titration, so this is the acid, the diluted acid, if you recall from the experiment. So it's a color solution. I'm going to add in thymol blue. So this is thymol blue over here. For the purpose of making it visually more appealing for this video, right, I'm going to add in more drops of thymol blue, but you know that whenever you add indicator into an experiment, you should only add at most 2 to 3 drops. Okay, so over here, I'm just going to add 1, 2, 3, 4. Okay, just going to add 4 drops so that you can see that the color is a lot more intense. Yeah, but do remember that this is actually a bad habit. Okay, so you shouldn't be adding too many drops of indicators. Okay, because indicators themselves are weak acid and bases. Okay, so this is a very intense color. So I hope you can recognize this. You can see that at the side, there's a bit of indicator and accidentally drop it in here. So what you can do is you can use some deionized water. Okay, but I'm not going to use too much here because if not, then my titration will be not so clear visually. Okay, so I'm just going to add in some deionized water just to wash them down. Okay, so you can see that this is a very nice intense pink. Okay, now the proper way to do titration, right, is your master hand should be holding your conical flask. Okay, and then your non-master hand should be the one turning the knots. Okay, so I'm just going to put like this. Okay,
So I'm just going to do the titration very, very quickly. So I'm just going to do a little bit of adjustment. I'm just going to adjust the burette a little bit higher so that you can see the swirling. Okay, so what you should do here is you shouldn't be adding and stopping and adding and stopping. What you should do is you should turn it to full speed first, and then you take note of the color change. Okay, is the color change very rapid? You can see over here that if I stop swirling, right, the reaction takes place quite rapidly. Okay, so I'm just going to continue doing a titration. You can see slowly it turns into a shade of orange. So I'm going to add dropwise. Okay, right. I'm going to maybe accelerate it a little bit as well. Okay, or maybe I can just continue the dropwise until you can see the very clear color change. Okay, so this is like orange. So a little bit of orange if I just stop. Okay, you know that the endpoint of titration is kind of like pale green. Okay, I'm just going to keep swirling. If you want to, you can add a little bit faster. Yeah, but there isn't a need to. Then until that, there's a very subtle color change. Okay, so I'm just going to stop for a while and then I'm going to continue to swirl. I'm going to stop for a while, continue to swirl. Okay, this is a bit like orangey, yellow kind of color. Okay, so you know that you're going to approach the endpoint. So very, very carefully, you add dropwise. Okay, you can slow down the addition until you observe that the green is disappearing very, very slowly. Okay, so right now you can stop. Okay, you take note of this. This is already overshot by a little bit. This is still okay. Okay, this particular color. Okay, if you take note of it. Yeah, because if I add in one more drop, the blue will be very intense. Okay, I just add one more drop for you to take a look. The blue will be quite intense. Yeah, so that color is actually okay. Can you see that this blue is now a lot more intense? Yeah, so just now, that endpoint is actually okay, but if you are not comfortable enough, you can do another titration by simply just reading off, and then maybe you just use that as a rough reading.
Okay, now that you have seen the titration technique, I'm just going to rewind a little bit. Okay, so let us just go back to this. Yeah, so just make sure that when you add in your indicator, you add only 3 drops, not more than 3 drops. I know in the video, I purposely added more than 3 drops. This is more of to showcase to you the intensity because I'm taking a video, so it's very difficult to see it if it's not so clear. Okay, yep. Then in the course of your titration, do take note of the color change from yellow to green, and then in your table recording, you should be recording the final burette reading. So you should be copying this in your table, and then initially you should be recording the initial burette reading. Okay, there is another pitfall that some of you might not be aware of. That is in the second step of part B. When you are pipetting out 25 cubic centimeters of the diluted FA1, many of you actually did not rinse your pipettes. Okay, you use the same pipette over here. Yeah, do take note that your first pipette contains the concentrate, or rather the original FA1, the undiluted one, and then in your B step 2, right, you are supposed to pipette out the diluted one. So because of the little bit amount of undiluted FA1 that remains in the pipette, you will notice that your titre value, your first titre value, to be of the high side, to be on the high side. Yeah, so just in case some of you were wondering how come your first title value is on the high side, this is something that you might want to take note of. Yeah, so do take note that for H2, for titration, right, you're supposed to titrate until 2 consistent title values within 0.10 cubic centimeters. Yeah, this is something that is quite crucial. So I hope you are aware of it and you practice that. And do not keep performing the titration as though like because it's very easy, right? Eventually you will find titration very easy. Then in assessment, you might feel that, oh, I just want to keep doing titration over and over again. Do not do that, because you'll be wasting precious time. So I mean, you will, when you get 2 consistent title values within 0.10, you should just stop and move on. Yeah, you shouldn't be doing you shouldn't keep repeating until you get the same values. Yeah, this is not something that is required of you. Just take note of it. Okay, so just ensure that they are within 0.10 cubic centimeters. Do take note that it's 0.10, not 0.20, because some of you in secondary school, perhaps the requirement is less rigorous, so you were told that 0.20 is acceptable. No, for H2 Chem at A levels, 0.10 is the accepted ones. Okay, and when you're recording your titration result, just take note that a table like this is more than sufficient. Yeah, so you do not need to have lines in every row. Okay, so this is not necessary. This table is quite a good showcase of what a proper recording is like in an assessment setting. And do take note that you are recording the initial burette reading, you're not recording the initial volume. Okay, so as mentioned quite often, what you are recording of the burette is actually a reading and not the volume, because if you haven't even dispensed anything, how can you have a volume of 0.05? Yeah, all right, this is the reading that you are recording, and the difference between them is the actual titre value you used in your titration. Yeah, so you can see in this particular sample scripts, the two readings are within 0.10 cubic centimeters of each other. Yeah, so after that, the students simply just take the mean titre value by showing the working here. So add the 2 up, divide by 2, and then the value is 22.85 cubic centimeters, and this is quite close, in fact very close to the one I got, because on that day when I performed the titration, I got around 23.00 cubic centimeters. Yeah, so this is a good titration result. Okay, perhaps I will just want to take this opportunity maybe to share a little bit about the titre values that you can select. Yeah, because for example, for this particular student, I just give a random example here so that it's easier for us to discuss. So let's say the student's first titre value is 22.90, the next titre value is 22.80, and then let's say the students perform a third titration. I mean, just random examples that I'm going to use. So let's say the student performed a third titration, right? The student got 22.80, for example, cubic centimeters. Then some of you might be thinking, when I take the mean titre, do I take all three? So the answer is yes, you take all three, because all the three readings are within 0.10 cubic centimeters. Yeah, so it is perfectly fine if you take all three. Yeah, if you choose to take these two, is it fine also? Yes, it is fine as well. Yeah, so please take note of this. Okay, so you can either take all three, or you can take the two that is 22.80. Okay, so this is the first example I'm going to illustrate to you. Yeah, so what about another example that I'm going to show you? Okay, so let's say the titre value, for example, when these students perform the titration, right, it's not 22.80. The student got, let's say, 22.95. Okay, yeah, and this is a little tricky now. Do you realize 22.95 is a little tricky? Yeah, because there are two ways the students can calculate the title, the average title. Okay, in one way, I'm going to highlight in blue. The students can take 22.90 and 22.80. So that's fine, because they are within 0.10 cubic centimeters. Okay, the second way the students can do is to take 22.90 and 22.95. That is fine as well. Yeah, but what the students cannot do is to take all three. Okay, so taking all three is not acceptable. Yeah, that is something I thought I want to share with you, because in certain situation I did not manage to maybe share this in the tutorial setting. Okay, yeah, so do take note of this, because this is one way. Yeah, sometimes it gets a bit confusing, especially during assessment. Yeah, but the simplest way is really to ensure that once you get consistent title of within 0.10, so that is For example, in the case of this sample scripts, the student already got the mean titre, or the two titre values within 0.10 cubic centimeters apart, and that's about it. He or she can stop and then move on. Yeah, so this is making good use of your time. Yeah, if you overdo your titration, sometimes you are just again wasting precious time. Okay, yeah. So with that, I'm going to move on to the calculation. The calculations for practical one is quite straightforward. Okay, so so for example, in C1, right, you're supposed to calculate the amount of sodium hydroxide present in the mean titre. Okay, since in the beginning you are given the concentration of sodium hydroxide to be 0.10 moles per dm cube, all you need to do is to calculate the number of moles of sodium hydroxide. This is a perfectly acceptable way of representing number of moles or amount. Okay, as I mentioned maybe in the review, amount of something in H2 Chem, right, it almost always means number of moles. Okay, unless we ask you to calculate the amount in grams. Yeah, sometimes Cambridge does that, but not often. Yeah, so amount is always in moles. Yeah, so you notice that the students performed the calculation and then left the answer, the intermediate answer, to 4SF, and of course the final answer, he or she left it to 3SF. That's perfectly fine. Okay, and of course you know that sodium hydroxide and hydrochloric acid react in a 1:1 ratio. So therefore, right, the number of moles of HCl present in 25 cubic centimeters of the diluted FA1. So sometimes if you don't want to be confused, you can simply just say amount of HCl present in 25 cubic centimeters of diluted FA1. Yeah, this might make it easier so that in the course of your calculation you don't get confused. But of course, you also notice that this particular calculation is quite straightforward. So you don't need to write too many words lah. But later on in topic 3 under stoichiometry, the calculation can be a little bit tedious. So it's better if you are explicit in the way you write your statements. Okay, and because of that, if I want to find out the amount of HCl present in 250 cubic centimeters of undiluted FA1, sorry, of diluted FA1, so this is of diluted FA1, right? Then you have to scale up by 10 times. And okay, so basically just times 10, and then you get 0.0229. Okay, and then of course from here, the number of moles of HCl present in 250 cubic centimeters of diluted FA1 is the same as the number of moles of HCl present in 25 cubic centimeters of the undiluted FA1. Yeah, so this is the same as 250 cubic centimeters diluted FA1. Okay, yeah. Then after you can just perform the calculations, and then you will be able to get the molar or rather the concentration in moles per dm cube, and then the concentration in grams per dm cube. Okay, so maybe in terms of the statement, it might be clearer if the student mentioned concentration of HCl in FA1 in moles per dm cube. Yeah, this might be a little bit clearer, and then this one will be in grams per dm cube. Yeah, so this is more of a proper way of writing statement. Other than that, I think it's perfectly fine. Okay, yeah, so I think that's the end of the calculation. After that will be the evaluation components. So for part D, suggest why it is necessary to dilute FA1 before the titration. If you recall what I mentioned earlier on, I mentioned that the concentration of the undiluted FA1, or rather FA1 as it is about 10 times greater than that of FA2. Okay, so because of that, right, you notice that your titre value is about 22.85 for the if you titrate sodium hydroxide with the diluted FA1, which is hydrochloric acid. Yeah, so if I were to just ask you, okay, so if I just titrate directly, what do you think would the titre value be? I think most of you, if not all of you, can easily tell me that it's 10 times greater. So I expect about 229 cubic centimeters. That's a whopping 5 times, I think about 5 times the volume capacity of the burettes. So that means that in the course of your titration, right, you need to top up your burettes 4 times before you can get 229. And in the course of topping up, right, you need to perform you need to read off the burettes in a total of about 8 times, right? Because for every titration you do, there is an initial and final burette reading, and then when you top up, you do another initial burette reading, and then after the titration you do another final burette reading. So so number one is, if you keep topping up your burettes, what is the issue with it? The issue with it is, of course, you're wasting resources, right? Because a lot of water is, I mean, the solution is made out of water, so you're wasting precious resources, and of course precious time as well. Yeah, so of course, most importantly, because you're reading off the burette quite a number of times, you are introducing a lot of errors in your reading. Yeah, but this might not be super crucial, but of course it's a combination of factors. Yeah, wasting of precious resources, and of course topping up the burette is definitely not a good practice a chemist will embark on. Yeah, so where possible, right, the burettes should only be used as it is. So the maximum volume that you can dispense from a burette is 50 cubic centimeters, and therefore in any of the titration we plan, there will not be a need for you to top up your burettes, because this actually constitutes bad practice. Okay, and you also notice from secondary school that whenever you perform your titration, right, your burette your titre value will be quite close to the amount or the volume you pipetted out. Yeah, I use the term quite close, but in most cases it will not be very close. There is kind of like a unwritten range. Usually it's between 15 to 35 cubic centimeters. So that is the range we are looking at. Okay, so just take note of that. I think that's about it for part D. Okay, so when you answer part D, right, there is a need for you to not only mention that, I need to top up my burettes, but also address the issue associated with it. Yeah, so this is more crucial. Okay, and then of course for part E, suggest another possible indicator. Usually we suggest indicator that are known, so not just a universal indicator. Okay, so what is known to us is methyl orange, either methyl orange or phenolphthalein. Yeah, so methyl orange is something that we are very familiar with. So methyl orange in acid solution is red, so the color change will be from red to orange. Okay, I do believe that in secondary school you are also familiar with an indicator known as phenolphthalein. Okay, phenolphthalein is easier to track actually. The color in acidic solution is colorless. Okay, then when it's a bit alkaline, it will be pink, so it's colorless to pink. Yeah, so these are the two you can choose. Okay, yeah, so for part F, the error associated with each burette reading is plus minus 0.05. Question is quite explicit. Explain how an error of plus 0.10 may arise. So they are only looking at plus 0.10, okay, when using a burette to obtain an individual titre value. Okay, so how is this possible? Like how can we get an error of plus 0.10? Okay, it is possible because for example, my initial burette reading, right? Okay, maybe I read it as a value x, okay, let's say x, but it has an error of, let's say, 0.05 cubic centimeters, for example. Okay, and then my final burette reading, okay, I will read off as y, right? But this y, right, has an error of, let's say, plus 0.05 cubic centimeters, for example. Okay, yeah, so in that case, the total error, okay, that arises is plus 0.10. Yeah, so that is kind of like how you can position your answer to be a little bit more explicit, focusing on what the question wants rather than a very generic answer. Because I know that, of course, some of us who does physics, you know that when we are given the error plus minus 0.05, when we are supposed to calculate the the error associated with the burettes, we tend to just take 0.05 times 2 because we are reading off the burette twice. But that's perfectly fine. There's nothing wrong with it. Yeah, except that in our case here, because the question was quite explicit in saying plus 0.10. So because the question is explicit, then I think our answer has to target to what the question wants us to do. Okay, then G is quite straightforward, but of course for most students, most of the students who got it incorrect, so-called, that's because you miss out an important point, because you are supposed to just measure out 25 cubic centimeters of hydrochloric acid. Yeah, so therefore your denominator must be 25. It's fixed. Yeah, the only one that is not fixed is of course the error, because the error is fixed, is associated with the instrument. So for pipettes it's 0.06, so just make sure that you indicate that clearly. And for total error of the burettes, okay, it's 0.10. Yeah, of course the mistake that students make was that they don't use 25.0, they use their titre value. Yeah, but if they use their titre values, the result will be quite similar, but then there's no point in comparing the two because the denominator is different. Yeah, so in assessment, if you do that, then I'm afraid that you might not get the credit. Okay, yeah, so that's the end of the review to practical 1. I hope you find it useful. So just make sure that you might want to rewatch the video on the titration technique that was posted, so that you are more ready for practical 2.